Hi everyone, it's Mr. Barden here. This is going to be a continuation of my Teacher's Edition kind of series of the Programming Digital Media course content. I'm going to be trying to record several videos kind of together at once and then periodically release them onto YouTube. So if you're watching this well in the future, back to back to back, you may notice that these are all kind of recorded well back to back to back, but I'll kind of space them out just to not uh, ruin the time of any of my subscribers with notifications and things like that. With that being said, again, this is the teacher edition, so I'll be going through the course content, but I'll be giving various kind of comments and suggestions and things like that geared towards teachers that will be teaching this course or one similar in your local high school program. So if you're a student of one of these courses, this may not be very useful. If you're just trying to, learn stuff, how to work with different things, may not be the most useful thing. I'd recommend checking out some of the other videos on, my channel as well as just YouTube as a whole. But if this seems like something up your tree, then welcome. Before I hop into it, again, if you enjoy the video, learn something, feel free to like, subscribe, all that YouTube stuff. If anything didn't make any sense, you want any further elaboration, definitely put that down in the comments, and I'll see those. And if there's anything that you want me to specifically discuss and go over in its own unique video, also put that down in the comments below. I'll see those. I've got a playlist going, so whenever people ask, how do you do blank? If it's something I can do, I'll make a video for it and post it there. So with that being said, let's just hop into it. Um, this lesson is going to be all about variables. So variables, it's important for the students to kind of get this conceptually because being able to make and utilize these is going to be necessary for essentially everything we do for the rest of the course. So if they understand absolutely nothing else, if they can do this, that's like the absolute bare minimum kind of a thing. But it is very important. So up until now, we've been putting in numbers, things like that. Um, just typing it in. So I've got, for example, right here on the screen, um, let rect height equal 200. And we'll break down all those steps with these numbers, this 200 right here, the 600 and stuff we're adding in the create canvas, things like that. That will those are what we call hard coded numbers. And essentially that just means that for as long as the code is running and existing, that value will always be that value. It is, set in stone, hard coded. Um, that doesn't have to be the case, however. We can have much more dynamic and changeable things in our code. We can store values in the system memory to be able to use and reference later. There's a lot more useful things we can do with our code. And to do that, the variable is kind of the base level of that. So again, we've got this kind of embedded code here. I'll just kind of scroll through it, but you can come check out the textbook. I'll put the page here in the description of the video. Um, and you can kind of see that, instead of numbers everywhere, like we had the rectangles we've done before, we can have rectangles, but there's now words. And in this particular editor, they're colored blue. And when I do it in P5 with my color scheme, it's pink. The point is they pop out. There's something unique and something different. Um, to make a variable, to make it and use these values, how I've mentioned, before we even start doing stuff with it, there's kind of three main steps to go about doing that. The first step is to declare the variable. So in order for these to exist, the computer has to allocate memory to that variable. And there's a set process it does it. We don't get into all that, but there's a way that the operating system and the motherboard and the CPUs and they do all that. I won't get into that, but you have to tell the system memory, hey, this variable exists. You don't necessarily have to give it a value yet, but you have to tell it that it exists, so that way you can refer to it by name later. Okay, and that's the key to variables, is that you have a piece of data, or multiple pieces of data sometimes, that have a unique name that you can then refer back to whenever you need to. And it kind of is almost like fill in the blank, put the value here for whatever's stored in this place. I like to think of it kind of um, like a leftovers container, Tupperware, something like that. I've got a little bit of the high pollen count, so I'm a little coughing more than normal today. So I got my cup here. But this cup, you could, the cup could represent a variable. And I usually like to bring in something physical for my students to kind of help grasp this. Okay, here is the cup. The cup exists. This is, I could do this actually. I've given it the name cup. All right, cup always exists. At the moment, cup here is holding some diet soda. Um, and that's great. I can be like, oh, what's in the cup? Diet soda. Okay, let's use it somewhere. Ah, cool. But at any point, I can change what is in the cup. I could put water or lemonade or iced tea, or I could, completely remove it and shove a bunch of ping pong balls in there. It doesn't matter what is in it. It's just that the cup is a container for something. In the real world, this is, an object. You can use a toolbox, you can use a lunchbox, whatever works for your metaphor and what you have. But for the computer, this is all virtual things. All it's data, numbers that we are storing in the system memory to pull back and use. Okay. So there's a few ways we can go about making variables, but I'm going to highly champion the use of the word let right here. So a few years back from when I'm recording this, they kind of updated a lot of what JavaScript is and how it works and some of that stuff, added some new features, things like that. And one of the things they did was they moved to the keyword let, which tells the code running JavaScript to make a variable. We're going to let this exist. We're going to make it be a thing. Before we had other words that would specify, var for var for variable. As we get into the Arduino section, you get character, Boolean, a bunch of different keywords. But let in JavaScript is kind of a universal catch-all for we're making a variable type thing to stick in our system memory. So that's how this course will be structured. It's all going to be let, unless I didn't make the example, and I don't have a way to update it. But let will be the keyword for making this variable. And I've got this right here. So you say let space, and then you give the variable a name. And that is declaring the variable, just giving it that name in the system memory. The next thing you have to do is assign a value, also called initialization, or sometimes init for short. You can see it like that, but you have to initialize the variable by assigning it a value, and that's what the equal sign here is. Now, this equal sign is not like in math when 5 times 5 is equal to 25. I had to think for a second. 5 times 5 is equal to 25. They're the same thing on both sides. That's not what's really going on here. We are assigning the value to be the same thing. So we're essentially storing, in this case, the value 50 inside of the variable called rect height. So we're putting 50 inside of the container. That's what's going on. If we want to do the comparisons like you're used to in math, that's 2 or sometimes 3 equal signs. And we'll get to that when we get into the next section right here. Just be aware of that. So we are assigning the value 50 to the variable. I can't talk anymore. And that's what's going on there. Note that you don't have to assign it to initialize it right when you declare it. You can declare it and then later on initialize it with a value once you have a value for it. And that's kind of what I'm mentioning right here. I'm kind of going through this, but without really reading the text. So again, one thing to note is I've got right here, you can only initialize the variable one time. Okay, you cannot have 2 variables with the same name. That'll be the next thing we get into is the naming conventions. So again, we have an issue right here in this code of we've already declared the value x value and set it to 1. So we can't say let x value be 21 now like I have here on the screen because we've already declared it with the word let. You cannot have 2 variables with the same name because your computer is, again, very powerful but very stupid. It can't tell the difference between the 2 with the same name, so it would, freeze up and crash. Uh, Most modern code editors are a lot more user friendly, so rather than having everything crash, it just won't run and it'll tell you that it's already declared. So to make this work, you would essentially get rid of the word let down here in the setup function, and you would essentially just be updating your current value. So it would start with 1, and then it would be replaced with 21 later on. Um, and that's what's happening right there. So again, the whole point of variables, you can put a value in, and then you can take other stuff out and change it as we go. We'll see that a bit more in a second. In terms of names, you can effectively name your variable whatever you want. Okay, whatever you want, that can be what you name it. But, but there are some guidelines and just a few rules. Um, okay, so and I've got these on the screen right here. But basically, whatever your variable is supposed to be doing, you should give it a name that refers to that. Like I've got down here on this second bit of code, let circle X, circle Y, speed, jump height. These all are very clear. Okay, this is the X position for the circle or one of the circles. It's the speed of something, how high something jumps. It's very clear what it is supposed to be. These variables up top, X14, I just kind of keyboard mashed on that one. Bob, Sally, things like that. This is very confusing, very problematic. If anyone looks at your code, they're not going to know what the heck is going on, and they're going to think you're an idiot. Um, for a teacher, this is also very useful, and you can make this part of your grades. Of you need to be able to tell what the heck these variables do. So that's kind of I factor that in a bit to my grades, especially when I'm teaching them variables, because again, you can't just button mash and expect it to make sense, because later on, practically speaking, whenever you want to access the variable, you have to type in that variable name exactly as you typed it when you said let. Um, and if you just kind of key mashed, that can be very problematic. Some of the other ones you can probably manage, but again, it's just a bad time. Always make your variable names descriptive for what they're supposed to do. And this will just save you some time in the long run. A few other things. I'm just looking through to see if I have it typed here. Like sometimes you can get issues if you like start with a variable name with a number, things like that. It can be problematic. So I always give my word names lowercase, and then every other thing is capital case. We'll talk about that in a second. That's called camel case. Um, Actually, did I mention it here? Huh, I don't. That's weird. You think I would have. Um, all right, but anyways, that just makes it easy to see what it is, what it's supposed to be for, and just save everyone a lot of time when fixing problems. So I mentioned a camel case, and I've got right here on the screen the variable jump height. So what this will be, camel case is essentially everything is lowercase. You start with a lowercase letter, but the beginning of every word is capitalized after the first word, and that kind of just makes it. If you look at the top of the letters, it kind of has a hump profile, kind of like a camel. Coders are very creative when they name things. But that's what it is, and this way, because when you're naming stuff, when you add the space, that ends the name, so you have to combine it all into one little string of characters. So in order to make it easier to read, uh, every word, if it's multiple words, you just make the everyone after the first one start with a capital letter, and then just keep going, and that way you can read it. But it's all one word, and it fits in with everything. Okay, so what is going on here? Um, this is a very basic but kind of instructional use of variables. So you can have variables that are a fixed value, um, versus a changeable value. So the fixed values will behave just like a hard coded um, number. So it's not super useful, but you do have the ability to change things later down the line. So it could be potentially useful. But having things update and change is one of the main reasons we store things in the system memory. Again, the other one is just so you can refer to it for other stuff, and we'll get into that a little more practically as we continue through the course. But uh, a big reason we use the variables is to be able to store value, take it out, put a new value in, and have our code change. So what's happening here, if we just kind of break through what I've got, we've declared the rectangle width right here variable, um, and we've changed a few other things, but we're essentially making the rectangles. Um, but at the beginning of the draw function, we are taking rect width, that variable that we saved at the beginning, we are assigning it a random number between 1 and 400, or technically 399 if we want to get technical, but we're assigning in a random number. So every time the draw function loops over and over again, and we specifically set that to 10 times a second up here, um, that value changes. And since we are using that value to draw the pink rectangle, you can see that this pinkish rectangle is randomly shifting its width, but everything else is the same. And that's one way we can go about doing things, moving it around. I'll show an example in a second of, again, using this in a little less random of a way. Okay, so the next thing I have here are system variables. And system variables are useful and important. These are variables made by P5 and whatever code editor you're using that are managed with the by the system automatically. They already exist as long as your code is running. So you do not and should not declare these variables and try to make new versions. It's not gonna work. Um, you'll get errors that it's already been declared and things like that. And you can't just basically all you do is read them. You don't write to them. Um, so in this code here, um, basically you'll notice that there is no let mouse X, mouse Y happening at all. We just say mouse X, mouse Y, and this is the position of the mouse on the screen. And we're using that to affect the 1 point of the triangle as well as the color that we are filling it in with. So as I move my mouse around the canvas, every frame P5 is checking to see what that is, and it redraws the triangle at that spot, and it readjusts the fill for that frame based, again, because of the math we're doing as we go. So as we move it around, you can see the triangle is moving and changing, and the color is moving as well. The most common system variables that we use are right here on the screen. So mouse X, mouse Y, that is the current location of the mouse, horizontally or vertically. P mouse X and P mouse Y are the previous one. So whatever the location of the mouse was on the previous frame, basically you just have the first one, it moves into the second one, and that way it kind of keeps a memory of 2 frames worth of mouse locations, which can be useful. Um, Key and key code are used for identifying keys on the keyboard. Um, and I think actually that's backwards now that I'm looking at it on the screen. Key code is like a numeric representation of your keys on the keyboard, whereas key is like F, G, 7. It's whatever is going to be typed. I generally prefer working with key code just because it's a bit more specific. Width and height are the width or whatever you make the canvas with create canvas. That's those values get stored in the width and height variable. There's a few Boolean system variables, and these are just true or false, 1 or 0, that kind of thing. Um, there's a few of them, but the most common ones we use are mouse is pressed and key is pressed. And that is just during that frame, is the mouse a mouse button currently being pressed? Is a key currently being pressed? Yes or no? That's all that they do. And it's pretty useful. The last thing I want to talk about on this page is scope. So most of the time for this class, I tend to put things in the global scope, which means that every function in your code can access it. It's generally useful. There are reasons where you wouldn't want to or have to do that, but for this class, generally speaking, they tend to be that way. Um, and basically, all this it means is whenever you declare a variable, if you declare it inside of a function, then you can only use that variable inside of that function. So, for example, let circ size um, right here, and then we're initializing it in setup right here, and then we can adjust it in draw. We can do whatever we want, but here we would get a bit of an issue. Um, okay, yeah, here we go. So if I click the mouse, where is it on the screen here? There it is. Okay, sorry, I just didn't pop up very clearly, but with this color screen. But as I click the mouse, you'll see that these squares are popping up. These kind of pink squares underneath the circle. But we are declaring these locally within the mouse clicked function, which is just whenever you click the mouse, something happens. Um, and then boop, boop, boop. So we're setting the fill. We're drawing it based off of that variable, and we're console logging some stuff. Um, so we can refer to circle size with no problem because we declared that globally. But if I was to uncomment this line per the instructions and rerun it, we're gonna run into a problem. And actually, where is the console on this? I don't know. I never really used this here, but basically, we would run into errors because, in fact, let me just copy this whole thing into P5 where the console already exists. Um, yeah, there we go. Um, Error right there popped up. It says square size is not defined, but we defined it right there. So this could be an issue with your students when they say, "But I did define it. What's going on?" Well, if you've defined it inside of a function, you can only talk to it with this function. So because we're trying to talk to square size um, in a in draw instead of in mouse clicked, it's not working. You notice the entire sketch is pretty basically stopped, and we're getting issues. But if I comment it out, then everything works just fine. And we're every time I click, we draw that, and it gives us the global variable. So again, a global variable is again something that can be utilized wherever, globally by your entire sketch. That could be useful. That could be less so. It depends on um, the context of what you're doing. Things down here, this is totally fine. And in fact, you might want to do this because if you're never going to refer to a variable outside of a function, go ahead and make it local. That's totally fine. But if you are, or you might, go ahead and go global. That's kind of the fail safe of if you make it global, you won't run into the issues, but it does use more system memory that way. Because again, once this function mouse clicked, it's going to run, it's going to make the variable, do all the stuff, and when the function ends, this variable goes away, it gets deleted from the memory. That's why it says it's not defined. Um, and then but to make it globally, it's always going to be there and always be taking up that little bit of system memory. So it depends on what you need, what your students are doing. I tend to, when in doubt, tell them just to make it global. um, but that is an important aspect. To go back to the kind of house metaphor I used in the last video for talking about functions, it's kind of like you've got your um, what appliance do I want to reference? Okay, here we go. It's like having a TV. All right, and the TV is in the living room. You can't watch the TV from another room. You can only use it in the living room. This would be different than if you were, let's say, watching TV on your phone or your iPad or whatever you might have. But you could take that and use it wherever you want. It does the same thing, but one is a lot more flexible and can be used wherever, as opposed to one thing being fixed to one location. I was going to use a toilet as an example, but I couldn't think of a good metaphor for taking that around other places. But again, that's the general idea. Okay, so I've got a practice example here. And so I'm going to go through this, and then I'm going to go through this everything is a number section right here, using this sketch as the example for that. And that's going to wrap it up for this video, just so you're aware. So let's delete all of that stuff. Let's say function setup. Just bring it back. Function draw. Okay, we have a create canvas. I'll make this a little bigger. And then background 220. There we go. All right. So that's there. So basically, I think the thing is to make a square, circle, line, and triangle using variables. Make them all global. And then, I'm not going to add the additional ellipse. You can try that with your students. So basically, I'm going to make one of each of the shapes right here. So there's a few ways you could go about doing this. My recommendation, if students are having trouble keeping track of all the things, is to have them make the shape first, hard-coded, and then replace everything with a variable. So I'm going to do that. Rectangle, ellipse, line, triangle. There. Just delete these extra spaces. And I'm actually going to just get rid of that. Okay, so let's just start throwing these in. I'm just going to make them all green, just so they stick out a bit more. So rectangle, let's go. There's one. Ellipse. I'm just kind of putting random numbers in here for now. Oop, no, the X, Y width. I want it to be. There we go. Line. 0, 0, I'm going to just go ahead and do it like that. And then triangle is. I'm going to put it down here in the bottom. So let's say. There it is. 0, comma. 700. Maybe not. And then I'm just. That's what I was looking for. Okay, more or less. Let's make this 600 instead. There we are. I've got this. Let me just hide me so I can. Boop, you can see all the stuff. So here we are. I've made all the shapes, and I've already used a few system variables, which will be fine. But I did this on purpose just so we can see a few different ways that this could be potentially done by your students. So again, if they're having issues, I recommend making everything with hard-coded numbers first, and then you're going to essentially be making a variable for everything, every argument inside of each of these functions. So it's a lot of variables, but the idea is to get them to do it several times. And there's a few ways they could go about doing it. I'm going to do it 2 different ways just so you can see it. So let's say let rectangle x equal, and then we have 100. Rectangle y be assigned. I want to stress you want to say be assigned every as many times as you can instead of equals, just to get them in their idea that we are assigning this value to the variable it's not equal to. That I sometimes trip up on that myself. Let's see, we have 100 rectangle width equals gets assigned 250. Rectangle height gets assigned. What did I have? 300. All right, so I've got that right there, and I didn't mention this before, but you may have noticed it in the textbook. But you can set up multiple variables just on one line. That's totally fine. You can initialize them on that as well. Again, I'm showing you multiple ways to go about doing this, but now we can just go in here and replace these four numbers: rectangle x, rectangle y, rectangle width, rectangle height. And the picture should look the same. That's the goal, is it should look the exact same. And basically all that's happening is when we call the rectangle function, it is looking at this variable, and whatever is stored in that variable, it's going to fill in that number to the function that we called. So if I wanted to change this, maybe we'll move it over some. Maybe it's 150. And it just moves it. I'm going to bring me back now before I forget that I'm not in there. But again, as you change these values, you would notice that wherever they're being used down below, they change and update. So that's the whole point. It's a very useful tool. You can save it in one spot and it'll change everywhere throughout your code. One thing you'll notice that there's a few repeated numbers here. For the purpose of this assignment, I make my students make a separate variable for each of them. The reason being is even though they contain the same thing, they may not always. So again, we can independently take things out and put things into the variable however we need. But if you use the same variable in two places, those two places are going to change the same way with the variable that changes up here. So if I used where's a 100? Here's a 100 with the ellipse. So rectangle y here. If I put that there, it's going to work the same. But if I change rectangle y to 300, both of these things change. And if you don't want that, that's a problem. And that's where you would need to have two separate variables that you can change independently. And the fact that they, at that one moment, had the same value just happens to be a coincidence. It's just two separate values that we are monitoring and changing independently, and they just coincidentally started or at some point had the same thing. So, again, if you don't want that, to have a separate variable. So I've got that there. Here's another way you might see it. Let circle x, circle y, circle width, circle height. We set that there. We can go into like setup. Circle x equal gets assigned. This is 700, 250, 2100. 700 circle y. It's assigned 250. Circle width. It's assigned. It's not a circle, but I'm just going with that. 20. Circle height is 100. So now we can replace this. We have x, y, width, and height. That's kind of the standard order. We have circle x, circle y, circle width, circle height. Same shape right there. I think we're starting to get that. So again, at this point, they made all the variables. They then later declared them, or not declared, they declared them here, and then they initialized them down below. Totally fine. You could also see it like this. I'll do this for the for the line, but we can say let line 1 equal 0, or I'll say line x1 equals 0, like so. Let line y1 be 0. Let you could see this. This would be points off if you were following these assignment guidelines, because I'm asking for everything to be global. Um, these are local to the draw loop, but if you were to go in here and line x1, line y1, line x2, line y2, where did I? Oop, an extra in on line. There we go. That works because it's everything, we've made it and we're using it all in the same function. But you want to make these global. However, there's an issue. Let me just paste this here. We've got some issues here. So basically, we're getting into issues here. We can't talk. So all this global stuff, we make all the variables before the sketch starts, but we don't define width and height until we get to this create canvas function. Until this gets called and used, width and height don't exist. It's not a number. It's not defined, which we've got right here, and that's what's causing some of this error to pop up. Like the sketch only goes this far, because then we start running into issues with the line. So what we can do is we can just say let this, let that, and then after this we can then go in and say line x2 equals width, line y2 equals height, like so. We can go ahead and do that, but again, you cannot globally refer to things like width and height until you've already made it. So that can be an issue some of your students run into, is you have to make the canvas before you use width and height. Okay, and that's kind of the same thing I have here. There was another thing I wanted to mention. Oh yes, the names. So let me just go ahead and get these made real quick. That's pretty much all the combinations of stuff you could run into that at least that I have. So let's just go here and let's just say let's try x1 try x2, or try y1 triangle triangle, there we go, triangle x2. I'll come back in a second once I've typed this. Okay, so I've got the variables here. Again, it's a little convoluted. We could be like top, left, right, bottom. It depends on what you need, but it's very clear this is the triangle x coordinate 1. And then you can go down to your triangle here, which I would like to do. So we can say the order. This would be so let's just see left to, let's just say the order. So we have let's say middle, left, right. Is the order of these. So 1, 2, 3. So we the 1 is the middle point. So we could say you can even say like 1 is, 2 is, something like that, just so you know what points line up with what. Okay, so I made all of those. So I'm going to go into setup. Do all that right there. Width divided by 2. That's great. Height. X2. Assign 0. Y2. 600. Yeah, width divided by 2, height 0, 600, width, and 700. There we go. Equals width equal sign 700. So I'm just gonna, for the sake of my sanity, put those semicolons there, and now we can replace these values. So we get triangle x1, triangle y1, I know there's bugs. I'm doing that on purpose. X2, triangle y2, triangle x3, triangle y3. Okay, so there's a bug. That being that triangle y1 is not defined. So you may think, well, wait, triangle y1, triangle y1, triangle y1, what the heck's going on? That wasn't what I did, but anyways, basically, whenever you declare a variable, you give it a very specific name. The computer is going to look for that name to be an exact match to whatever you type. So tr lowercase y1 is something completely different than tri capital Y1. That exists in the system memory. As far as the computer is concerned, a capital letter and a lowercase letter are completely different. Right? They're completely different. Again, computers are powerful but stupid. You, as a reader, reading the code, would know that that's what it is. But again, this Y is different than that Y, so we get a bug. Computers are very literal, so that's what's happening right there. Okay, so that's the end of the variable section. So, if you had any questions about that, definitely pause this, put a little comment down below, and I can get back to that. But I'm going to move on to this next section I wanted to cover today in the last portion of the video. This one won't take as long. It's just about math. Um, so basically, when it boils down to it, um, everything is math. Everything is a number in the computer memory, which means you can do math and have all of these things change and adapt however you might need. So here's some basic ones. Addition, subtraction, multiplication, division, and modulo. I'll talk about modulo later because of all of these, this is probably the one you don't know if you don't know any of them. If you don't know these top 4, you may want to reevaluate your teaching career. Jokes aside. So to use the math in the code, there's different ways we can do it. So I've got this example right here. So we've got rectangle X and Y. That's the only variables we have. That's kind of the core of this sketch. Down here, we're making these multiple rectangles here. So we've got, this light blue one is rectangle, that rectangle X, we're gonna increase it by 40, and then by 90, and then by 140. Everything else is the same, and we get this row of rectangles here. If I change this to instead of 10, maybe it's 60, not 660, and rerun this, all the other rectangles are going to get confused. But now they've all kind of shifted over a bit. Again, they've changed. So that could be one way. If you know you have a group of things that are always going to be together, you can have one core variable that's kind of controlling the position or the whatever will change with those, and you can base it all around that core element. So that's what's happening here is we're just adding 50 each time. The pink ones, we're multiplying it, so they look the same. We're by 5, 10, and 15, rather than increasing it. So if I change the rectangle X to um, 11, 11 instead, you know, that's not that drastic of a change. Let's go 15, just to make it a little clearer. These pink ones are much more spaced out than these green ones up here. And we'll talk about each of them as we go through. But again, that's just by multiplying it, you can get the exponential growth for um, making things bigger. Subtraction, same thing. This is going to behave the same way as the pink ones. I just want to make sure to include it there um, as we go. And then we can combine combination things, multiplying, dividing. We can get some interesting. You just play around with the math. It gets exciting. The whole point of this thing is all of these are numbers. The variables are numbers. The numbers are numbers. That it's all you can all do basic math to it in order to swap it. And that's another thing is for this class you don't need to know advanced calculus and math. Just basic high school students can do this math. Um, what do I have here? So this one is a mix of that. Only now these blue ones. There we are. Now it's these follow the mouse. So as I move the mouse, you can kind of see how they all behave a little bit differently. So now those orange ones move down a lot more than the blue ones do. The pink ones are evenly spaced, but it's exponential. The green ones aren't. They vary as they go. So we can kind of see how over time and if things move by changing the math, you can get very drastic changes, even though these are very similar parts of the code. Um, One thing to note, I did this in the last sketch, so it's here, but once you've made your create canvas and set all that up, the width and height variables, that's very useful. That is, if this coordinate way up at top is 0, 0, this one down below, where you can't see my mouse, let me hide me. This one way down here, that would be width, comma, height as the coordinate. To put things right in the middle, you can just divide it by 2. So again, all of the width divided by 2 would stick you right here. Height divided by 2 would stick you right there. That's right smack dab in the middle of your canvas. And then that will, let me just bring me back. That will be able to center things, and it'll always be centered. So you could change your canvas size, but as long as something is at the coordinates width divided by 2, comma, height divided by 2, it's always going to be right in the middle of your canvas. That's a very useful tool, and you can kind of logic out, okay, if divided by 2 is the middle, divided by 4 is a quarter, multiply it by 0.75, that's 3/4, and you can very quickly proportionally space things out just by using that basic math. It's a very useful tool. All right, so for animating things, so we can apply this math however we want in the draw function. So right now I've got an arc which just draws a portion of a circle. We'll get into that more for the kind of advanced shapes later. But it's just a static image. This other one, let me just rerun it. You'll see the Pac-Man moves. There it is. One thing you'll notice that this doesn't have the background updating, so you can see the old Pac-Mans, and that's what forms as bars, as just being drawn on top of each other. So what we're doing here is inside of the draw function, what's happening is we have this line right here. And if anyone focuses more on math than computer science, you're going to look at this equation and you're going to get a headache. Okay, at this point, you should have had enough time to go get like an aspirin or something. What is happening, if we think about it as a computer, I'm going to do the same thing with this circle right here. I'll move it across the screen. So let me just move some of this stuff down out of the way. I like to personally do all of my math and then draw my shapes afterwards. That's just a kind of a personal preference. But let's get into it. So we can say circle X, there we are. It's assigned. We're going to give it a new value. That value being circle x minus 1. So now you're seeing that this is moving. What is happening is every frame we are saying, say, circle x, we're going to assign you a new value. That value is going to be whatever the current value inside of circle x is minus 1. So if I wanted to, just so we could see this, now we can see every frame we're just subtracting 1 from it, and it's causing the circle to move across the screen like so. And that's what's going on there, and it keeps going for infinity as long as this is running. And that's what's going on here is we're just taking the value, giving it a new value. We're taking, to do this visually, I've got my cup. There we go. It has, I don't know, about 7 ounces of liquid in it. I'm going to assign it a new value. Now it's got about 6 ounces of liquid in it. And that's essentially what's happening. So you can go in every frame, and you do this over and over and over again. That's what makes the animations happen. So we're just changing the value inside the variable, and because we are using that variable to draw the shape, that's where the animations begin to appear. Again, this one doesn't have the background updating like this one does. So because that background is updating, we don't see the older ones. It's just the most current. So it just looks like the shape is moving around. So we have that right there. Here's another one, I think. So if we run this, you should see it now with the whole shape just kind of moving on its own. There we go. Boop, boop, boop. There it is. So as a teacher, when I start off doing this concept, I will always type it out like this as a full equation. Variable gets assigned the current value of the variable minus 1. As we do it more and more, I tend to use these kind of compound symbols. So again, we have x equals x minus value. That's what we've done right there. But we could say maybe we wanted to move it faster and move it 10 frames every time. Circle moves a lot faster. To save time, because this is a thing that gets done a lot in coding, we can say, minus equals 10. Same exact thing. It's just a compound way of saying minus equals or multiply equal. That's gonna go way too fast. Or plus equal, things like that. So you can do divide equal, however you want. You can just compound that into a simple two symbol instead of having to write out a whole equation. Another thing is if you're only doing it by 1, which is even more common, you can do this. So let's say circle plus plus 1, plus plus 10. What? Oh, I'm sorry. It's not plus plus. It's there we go. So yeah, the value plus circle x plus plus. We could be minus minus. These are the more common ones you use because multiplying and dividing by 1 aren't gonna do anything. But you can just say the variable name plus plus or minus minus, and that will automatically fill in this equation with the value of 1. So it would be, this is a very shorthand way of saying circle x gets assigned the value of circle x minus 1. And we're just going to repeat that over and over again. So if you see this kind of thing a lot, that's what's going on. Again, I work my students into this kind of notation, starting with the full equation, working it into the shorthand. So that way they know generally what's going on. The last topic of this video is going to be modulo. And using it with animation, we can see some stuff like this happen. Let me just scoot it down a bit more so I'm not in the way. What we're seeing is a repetitive thing, repetitive motion. Let me use actual adult words. And basically what's happening, what the modulo is let's say you've got let's say you've got 5 divided by 2, or no, 2 divided by 5. 2 divided by 5 goes into their 0 times with 2 left over. So that would be the result of that is 2. 5 divided by 5, 5 goes into 5 with 0 left over. So the modulo value would be 0. 6 modulo 5. 6 goes into 5 one time with 1 left over. So the modulo 6 modulo 5 would be 1. Let me just kind of explain that a bit more with math. So instead of circle x going down like that, we'll say circle um, circle x equal gets assigned frame count modulo is the percent sign. Actually, let's just leave it at frame count. So as all the frames tick up, frame count is a system variable that just counts how many frames the sketch has been running for, and we're just using that number to draw the circle. So as we go, we can see the circle move. But if we modulo by width, let's just say, let's bring that back. We have this here. So we are currently dividing the frame count by the width of the canvas. And we're using that value to draw the thing. Every time we get a whole number multiple, it goes back to 0, and it keeps going. So it's going to go up to the width, and then because the frame count isn't exact, 5 goes it, or 15 goes into 5 3 times with 0 left over. So because that's 0, that leftover, that remainder of the division, that's what the modulo is, essentially. It's dividing things, and something's getting kind of laggy. I'm just going to do that. Something was a little laggy. My internet must be a little gross right now. Good thing I'm not streaming this. But that's essentially what happens. You divide stuff, and it is the remainder that's left over. The symbol is the percent sign. You don't necessarily have to use this, but I like to go into that. Sometimes I'll play a video about it for my students, but that's kind of a text description. And then actually this textbook has a link to, what is modular arithmetic. So basically, yeah, you normally get A divided by B equals Q with whatever left over. The R is what we want. We can ignore everything else. So, so 13 divided by 5 is 2, remainder 3. So 13 mod 5 is 3. So again, you definitely pull out this page if your students are a little unsure on the concept. But by doing that, we can get these repeated animations because, again, it's always going to reset back to 0 at some point. So I like to use the frame count because that's going to be a thing that always starts at 0 and just ticks up to infinity for as long as the sketch is running. So, that's just a useful thing to modulo against something else, whether it be the width, it could be some other number, it could be a variable, whatever that you want. But then that way you can get these repeated cyclical animations. That's pretty much it. In fact, one of the review assignments and one that I make the teachers do is to utilize all the drawing of shapes and modulos to make this on their own, where it's just a stick figure person moving from left to right across the screen, but it repeats over and over again with the modulo. So you first have to make the stick figure, do all the variables, and then start applying the modulo to kind of get all of that together. Down here is another sketch where basically you copy and paste this into a new sketch, make various variables, and essentially I kind of did the first one for you. make all the mouse X and Y, make all the circles follow the mouse at various distances using math. Um, so that can be a useful tool. I'm not going to get into that right now, but um, that's another assignment you could have your students do. Again, I make the teachers do the slightly harder one, just for practice. Um, and that's going to be it for this video. So to kind of start wrapping it up, um, the kind of again the short version is we have variables in our code which can be used to store data. We can look inside of it, be like, yeah, that's Diet Coke in there. Um, and cool, we can use that however we want in our sketch. We can take things out, so I'm not going to drink all of this at once, but we could drink it, fill it up with something else. Doesn't have to be the same thing as before. It could be a number, it could be an object, it could be a string, it could be whatever you want to store in here, you can put in your variable. That's the first part, and we can update that and have things change in our code if we want. And then boiling it all down, it's all numbers. So whenever you call a variable, the computer's just going to look inside, see what it is, and use that in the context you called it for. Because it's all a number, you can very easily do math with it. So we can say, circle X, and then we can add or subtract. We can do modules. You can do whatever you want with it with the basic math. So once you kind of wrap your head around that just as a concept, again, this doesn't have a whole lot of computer science, like type all the stuff. It's more conceptual lessons right here. But once you and your students kind of wrap your head around those two things, a lot of what's going on in these next few chapters kind of begin to click and make sense, at least for me. So hopefully that will be the case for you. If you enjoyed it, learned something, definitely give this video a like, subscribe, all the YouTubey stuff. If you have any questions or concerns, or maybe you want to see something specific gone over, put those in the comments down below, and I'll get to those as soon as possible. My next video that you'll see up here is going to be specifically on conditional statements. I'm going to have one video for all of that because it's a bit more of a beefy, also important topic. And then I'm kind of basically going to do one each for each of the lessons. So one on conditionals, one on arrays, one on loops, and then one on functions, and then objects and classes. And that'll be the end of Unit 1. So again, everyone have a great day, and I will see you all the next time that I see you. Bye.